Hello and welcome to another episode of SGTV. My name's Marcus Barrett and I'm part of the technical engagement team here at the Scolmore Group, and I'm joined by my colleague Tim Benstead.
Hello Marcus.
And what are we talking about today, Tim?
We're going to actually start looking at support for wiring systems, cables, conduits, and all the bits and pieces surrounding it, and perhaps look at some of the history that leads us up to where we are now and why we are where we are.
Okay, so what we're saying now is cable sports are not actually a new thing to BS 7671 as we know it as the 18th edition.
Absolutely. Cable supports have been in for donkey's years.
Oh, okay, lovely. Where would we like to start really when it comes to looking at the regulations? And maybe it's a good idea if we actually compare when I've got a copy here of the 18th edition BS 7671 and you've got, what edition is that?
14th. 14th.
I definitely prefer the size, Tim.
I prefer the size of the 14th, and this is the version I actually started with.
Really?
As an
when
apprentice.
You were training?
Yeah.
Oh, lovely.
So as an apprentice electrician, I started on the 14th edition.
Yeah.
So much easier than when the 15th came out.
Yeah. So when we're looking at and we're thinking about cable sports, before we go to that sort of section of the regulations, the first thing I want to just check, especially comparing to yours, is actually, for me, when we're talking about cable sports, is good workmanship. That's the first thing that comes into my head on being a contractor and how I present that cable and actually what's behind that. So at 134.1.1 within BS 7671, the 18th edition, talks about good workmanship and the use of good materials. Is that something that's relevant back in the 14th edition? Have we strived to change from the 14th edition?
Absolutely not. We know within Regulation 7 of the building regs, there's already a requirement in law for good workmanship and material, and you'll see nice big bold letters there, whether you can see that or not, but trust me, big bold letters. Part 1, first note in big capital letters, the 14th edition said good workmanship and the use of proper materials are essential for compliance with these regulations.
Yeah, and
not much change there.
Not much change at all, other than now actually the difference within that I can see within BS 7671 is we've got rid of the capital letters.
We got rid of the capital letters.
For the 18th edition. We also talk about now complying with manufacturer's instructions, which is something that wasn't mentioned there within the 14th edition. And we've seen that grow within the regulations where we're now taking manufacturer instructions into consideration.
Rightly so, because manufacturers design and build to a certain way, and therefore when we install, we should take account of those instructions.
Yeah, most definitely. At the end of the day, like you said, they've built it, they're the experts on their product. So yeah, we sort of go from there. But it's nice to see that actually back in the 14th edition, it was very similar in terms of promoting good workmanship straight away. Yeah,
and actually, Marcus, if you actually go further back and further back, long before, back when people were even older than I am, that hasn't really changed much.
Oh, it's still present within them regulations,
Yeah, that's been running through for pretty much the whole life of the electrical industry.
Yeah, it's good to hear, especially as, I don't want to say younger electrician, I'm not a younger electrician, but where I was training within the 17th edition and actually knowing the fundamentals I was learning was still back then. So we still have that element of workmanship trying to carry forward.
There's very real continuity, yeah, absolutely.
Lovely. So if we move now on to cable supports and supports for the wiring system, and we're going to look at regulation 522.8.1, Tim.
Yeah.
So I imagine within your 14th edition it isn't 522.8.1.
No.
But again, it will be nice to see where that comes from, and the reason we're sort of doing this episode as well is just to show that there is meaning behind cable supports and wiring supports, and it's not just there to make your life easier, but actually for other things. So should we jump into the 14th first and see what it says about
I have to say it's a wee bit shorter, so we're in section B of the 14th edition, and again, for those who are of a certain age, we all know what section B was. Here's our test. And B25 simply says, all conductors and cables shall be adequately protected against any risk of mechanical damage to which they may be liable in normal conditions of service. And there are other regulations around where they're buried under floors and ceilings and the like, which really haven't changed much either. But there is a general principle regulation within section B of the 14th edition.
Yeah, so what I'll do now is I'll read BS 7671, what we're currently doing on 522.8.1, and it reads, a wiring system shall be selected and erected to avoid during installation, use or maintenance, damage to the sheath or insulation of the cables and their terminations, the use of any lubricants that can have a detrimental effect on the cable wiring system are not permitted. So when we talk about evolution, actually the fundamentals from the 14th, it effectively is very, very similar, but we've sort of just slightly changed the wording and added in maybe things that weren't used in the past. So maybe lubricants we've had to take into account.
Well, we did have lubricants back in the day.
Okay.
It isn't that old, come on. It is only 1978, for goodness sake. That being said, we did. There will be, if we went hunting, there would be a regulation specific to lubricants. The 14th edition was clearly structured very differently.
Yes.
When the 15th came in, the restructuring took place, which was more familiar with what we have now.
Yeah.
But we do have information in here on cables of a certain type with certain types of material and so on and so forth. I mean, when we were drawing cables in, you were still told off for trying to use Fairy Liquid.
Oh, really?
Other products are available for trying to get a decent drawing in of cables.
So, and again, what I take from them regulations as well is we're still using that word shall, aren't
Yes.
we? So nothing has changed in terms of the 14th edition to here. This is still a requirement. It's you shall do this. And how can we do that when we talk about cable sports and wiring sports? What sort of thing can we do to ensure that the terminations are not under a mechanical undue stress?
Yeah, I think probably we need to touch on something that was a change made more recently within the standards, and this is the issue around premature collapse. And perhaps refer it also to the requirements within BS 5839 Parts 1, Part 6, 5266, 8519 for actually ensuring the integrity of the cable signal. And on the premature collapse, making sure that there's no risk of entanglement. I think we need to touch on that probably as part of this discussion of just around saying, well, we need to get the bending radius right, we need to get the right type of clip for the right type of thing. So there's a broader chat, I think, to be had, perhaps before we get down to the nitty-gritty of which clip would you use or which support mechanism would you use for each of the circumstances in which you find yourself.
Yeah, and that's part of the evolution between this, isn't it? I imagine in the 14th edition there isn't much about, or anything about premature collapse of the wiring system, because we've seen that as an addition to this set of regulations we're working from now. But it's interesting you mentioned there about the communication signal within BS 5839, so that's not actually something I was aware of. I always presume that, let's say a fire alarm system, we would use FP200 and we use metal clips because of that reason, premature collapse, whereas actually it's not for that.
No. And again, back in the day, FP200 didn't exist. We had MI, mineral insulated, or pyro as it was in the day, and you didn't really think too much about it. But you still had the recommendations within the relevant fire standards of the day, because it wasn't 5839 then, to maintain the integrity of the signal. Because in the end, when all else is failing in terms of the wiring, you want the fire alarm system, the emergency lighting system still to be working.
Yes, because you still want people to be able to evacuate. You want that process, I imagine, to last as long as possible so that it ensures the safe evacuation and, of the building.
Because you're not worried about rewiring, you're not worried about maintenance of the cable. It's going to be rewired. You know, if there's been a fire, if you're not pulling the building down, it's going to be rewired, however long that cable lasts. And so you deal with these things sort of carefully, but back in the day, it was a case of that was the only thing we were concerned about. Premature collapse never was considered.
And again, it just shows that level of evolution, isn't it? And where we go from there. Again, whether what you were saying there, it's nice that actually BS 5839 and BS 7671 took different sort of methods to get there, but now they're sort of aligning with actually using these non-combustible fixings such as for trunking and tray, etc., with the metal cable ties. So it's nice to see how their standards are starting to align in a certain way. So now we've sort of looked at the furthest point of evolution in terms of cable supports in premature collapse, Tim. I just want to rein it back in a little bit, because I remember very fondly when I was at college, and maybe you do as well.
I still remember being at college.
I would have a bit of A4 paper, I would have to draw a circle with a certain diameter or radius, and then I'd have to bend my cable around that,
the edge of it.
And I remember that being the bending radius of cable.
It was only a little short bit of cable that they wasted
very short bit. It was. So is that something that is in BS 7671? Because I remember using the on-site guide for that mainly, not BS 7671. But is that something actually that would be in the 14th, or did you have an on-site guide?
No, we did. We did not have an on-site guide. We had the regulations, and it was in the regulations. It says the internal radius of every bend, regulation B32, the internal radius of every bend in a cable shall be not less than the appropriate value stated in table B 1.1m.
Okay, so you actually was given the table within the regulations back then.
Yeah.
Whereas opposed to now, we still have information here regarding the bending radius, but then we would have to go and look in the on-site guide.
Yeah.
And I believe it's Appendix D, Table D5 when we're looking at bending radiuses. And I remember it would give us the cables on the left-hand side, and then it would give us factors we'd have to apply to the diameter of that cable to how it was bent. Is that very similar still, or has it changed much?
It's the same. It hasn't changed at all. So if you picked up the 14th edition and looked at the minimum internal radii of the bend, you would get the same factors.
Oh, wow. But I suppose the only difference really is back then you was using, I say back then, I don't mean it like that, Tim, I promise. But we was maybe using different types of cables where now we mainly have PVC.
It's always PVC.
Oh, really?
In fact, fortunately, I'm not that old, so I didn't have the worry of trying to carry lead cable on the back of a push bike, which the electrician that was my electrician used to remind me of, that carrying 50 yards of the equivalent of 2.5 lead on a push bike was hard work. Because the firm van, there was only one of them. And there you go. But that is really showing just how desperately old and tired.
So now you've seen how electricians have evolved. So we have Tim and then we have me.
And it's your good fortune as you get older to go as bald as I am.
So when we're talking about bending radiuses then, why... break it down a little bit. Why is it important that we have a bending radius? Why can't we just go, yeah, that looks about 90 and then that's absolutely fine?
It's an important question, I think. It's the recognition that the minute you start putting a bend around, shall we say, the flat part of the cable that you're working around, the internal conductor within that is bending more than the external one.
Oh, okay.
So inherently, that turning of that cable around that radii means that you're actually making sure that the one on the inside of the bend is not stressed, because the outside one won't be in the same way. And when you bend it round, you've got to remember you've got internal insulation that you're then forcing against an internal CPC perhaps, or actually if there's no CPC and it's thing, but you're actually forcing the two conductors' insulation to bear onto each other in such a way that there is a risk, and again we're dealing with risk factors here, but there is a risk of parallel arcing over time being created because you've created damage to the
insulation of the cable. And again, that sort of cements what we spoke about at the start of this sort of episode, where we firstly went to good workmanship.
Yes,
absolutely. That again is good workmanship, and we're trying to keep the longevity of the installation for as long as possible. And you know yourself, a very well installed installation will normally outlast most things. As long as without obviously fires and things like that.
Absolutely. So, PVC, we still haven't worked out when the end life is of PVC.
No.
You know, it's been put in since the 1960s and it's still sort of working quite well. So, you know, PVC has an excellent lifespan. And as long as you rightly say, work it properly, do a good install, it's going to outlive you. Yeah,
definitely. And again, so there's a bit of importance around bending radiuses, and you probably remember it at college, but when we look at the regulations, it is in the regulations that we need to take that into consideration. It isn't just something your tutor maybe said to you and you think, oh, why am I doing this? It is there for a specific reason. So now we've looked at bending radiuses, Tim, where are we going next?
We're going to start dealing with fixings.
Oh, okay, so we're going to be looking at the actual supports that we would use for our wiring systems, or let's say our trunking systems, our conduit systems.
And whilst they're all different in essence, they're all actually conforming to the same requirement within 7671. It doesn't change, you just have a different mechanism for holding stuff up.
All of them supports do the job of making sure there's no mechanical undue stress on the containment system, on the conductors themselves.
Yeah, that's absolutely right. And so for example, let's deal with just cable, you know, insulated and sheath cable. What are the ways we have of fixing that now? What, clips?
So we'll have what we conventionally call maybe a twin and earth clip or flat cable clip. And again, just quickly, that goes back for me to good workmanship, because when we're talking about good workmanship and using the right materials for the right cable, I know it seems very small, but actually using the correct clip for the correct type of cable, we wouldn't necessarily want to use a flat PVC clip on, let's say, a round flexible cord, because we then have a chance of driving it in too hard, causing a pressure point within that system. And again, that good workmanship, the longevity of the installation. So even though these small details may seem a little bit, is that are you going too far with it? Actually, they're very important into the longevity of a system.
And also trying to put a normal sort of cable clip into a wall that's actually not suited. I mean, for example, some thermalite blocks. You stick a clip in there, it
just
falls
straight out.
And so you've got to remember that the nature of the clip for the cable is important, but the nature of the clip for the wall
Yeah.
is important.
And ultimately for the environment as well. If that cable is going to be accessible, then we may need to look at clipping distances. So again, we'd look in the on-site guide. I imagine there's another table in there. Is there for clipping distances? You was fortunate enough to have it all in one document.
Yeah.
So
table B2M.
Oh, lovely. So we would look at clipping distances and stuff like that for accessible cables. If a cable, however, was run, let's say, above a ceiling, is there the necessary need to provide cable support?
Well, you need to make sure that the cable's not going to be liable to damage.
Yeah.
And so the question then arises, what are you likely to be stuffing into that ceiling that could damage a cable that's just laid on the back of some plasterboard?
Yeah.
And so the same question arises is if you can guarantee that nothing's going to damage that cable, okay, but if you can't, and you probably can't, then you need to be thinking about holding it up somehow.
Yeah, exactly. And even though the clipping distances might not come into play there, it's still, for me, as a contractor, is good to follow that, because then you know that the cable itself, because again, we have to talk about the weight of a cable. That can actually cause undue stress on itself and the termination. So no matter how we're running our cable, we definitely have to think about the supports and the clipping distances, etc. Same with conduit. Isn't it? Yeah, we don't want conduit hanging and sagging, because we generally would have a single insulated cable inside of there. And if we cause too much sagging or problems with the conduit, it could create sharp edges, etc. and damage.
And also, if the gap between the fixings is so great, then the risk of accidental pulling off a wall increases, simply because you're actually requiring more of those connection points than is wise.
Yeah, exactly. And again, it just goes back to good workmanship.
Good workmanship materials. Regulation 7, Note 1, and Part 1 of the
current standard. Yeah, and it's there at the start for a reason, because it seems, as we go through this book and we do these episodes, that actually most of these regulations we touch on refer in one way or another back to the very first part of the book, which is good workmanship, the use of good materials, and following manufacturer's instructions.
Because let's be honest, with that, Marcus, the issue isn't just a case of saying, well, it's the right clip. If it's not installed in the right way on the right wall, there's a fundamental problem, and the workmanship bit's dropped away, even though it might be the right materials.
So it's a good point, actually. You've got the right clip for that piece of cable, but you haven't installed it at the correct distance, which has then caused the conductors to come under undue stress and cause a problem within the system. So it's a great point that I didn't necessarily think about. Fixing to thermalite block and it falling straight out as a contractor. Sometimes you would just fix it. If it stays there, you're happy. When actually that's not the way we're sort of doing stuff.
And then, of course, we've still got things like fixings for conduit, whether it be plastic or steel. If you're thinking about the nature of those fixings, then the nature of the saddles becomes important, doesn't it?
Yeah, of course it does,
So, Marcus, what about conduit saddles?
Yeah, so when we have to look at conduit saddles, again, they're not just a one-size-fits-all, Tim.
No.
We have to look at the different environments we're installing in. And we have 4 common saddles, really. We have the saddle, a spacer bar saddle, a distance saddle, and a hospital saddle. And generally, depending on the environment we're installing in, let's say we've got somewhere that's high hygiene, maybe a hospital. A hospital saddle isn't just used for hospitals, just places of high hygiene, so makes it easier to clean behind. And then we might use, let's say, a distance saddle for where?
Perhaps if you've got uneven walls, so that it provides sort of a level of continuity and not stressing him. So when you're actually pushing the conduit back in, you're not actually putting a real level of ping on it.
Because you're effectively putting strain on it, and then it's trying to force itself back out.
And you're relying on those 2 little screws at whatever point of strain you've got to hold it on.
We have a saddle as well for normal surfaces, so flat surfaces, and then a spacer bar saddle, again, is used conventionally. We don't really see saddles now. Used to see them with the old black enamel conduit systems, but now it's generally a spacer bar saddle. But I remember when, obviously, I was training at first and I was installing conduit. If I was installing a plastic conduit system, Tim, the saddles would always be plastic. If I installed a Galvy conduit system, they would always be Galvy. Is that the case now, or have we evolved from the way we do it in terms of premature collapse?
Problem is, I'm a bit of an old beggar, and you see these soft hands. The last time they touched conduit was an awful lot of years ago. In fact, you're better suited to telling me that. I mean, you're absolutely right. It used to be, if you're putting PVC conduit in, you put in PVC saddles, and the nature of that perhaps changed simply because the issues around premature collapse and the fear that under increased heat conditions, the risk of that saddle failing and causing a conduit to fail perhaps sits there. There isn't a specific requirement in 7671 related to that. The original reason why we included a requirement around that was the issue around PVC trunking, lids popping at relatively low temperatures and conductors dropping out.
And then causing that entanglement because they fell out of the containment. Rather than the containment melting away, they've actually fell out of the containment prematurely to the premature.
Hence the saddles, you could put an internal metallic saddle to hold them in, or you could put something around the outside of the trunking to hold the lid on.
Yes.
We didn't, as a committee, we didn't care which one you did.
Yeah.
We just cared that there was no risk of entanglement, and that's why it was sat that way. Yeah,
generally industry now, rather than putting some around the lid, we have something like these here, where we insert this into the trunking, we fix it, this then wraps around the cable, and so that makes sense now. I actually never knew about the lid popping. If that lid pops off, this actually holds the cable in place anyway, as opposed to the trunking melting away from the wall.
That's exactly right. So it's relatively straightforward in terms of why it is we do some bits around those elements, but it doesn't change the nature of the requirement for the fixings, whether it be conduit or PVC or other types of insulated and sheath cables. The requirement for these systems to be held in place safely and under no stress, or under a stress that's manageable for those types of systems, is critical insofar as the requirements of 7671 are concerned.
So Tim, the last one I sort of really want to look at, because we've looked at most of the regulations now in terms of cable supports, is 522.8.5, which again talks about mechanical undue stresses on the terminations and the cabling itself due to its own weight. However, there's a nice note in here that talks about consumer unit meter tails are part of this requirement. So is that something that we've seen within the 14th edition?
No, we didn't see a specific thing, and actually that is an excellent development that's appeared within 7671. And again, it's not been in 7671 all that long. It's a relatively recent development to include that, quite simply because it's a recognition that it's easy, isn't it, for the weight of the tails, or if somebody walked in on something and they catch the tails, to actually make a problem for any connections that exist within a consumer unit.
Yeah, and again, as electricians, we have to look at where that supply head is, where we're taking our tails, and maybe there by a front door where we have shoe racks where children are going to be. If them cables are under their own weight and they're easy to grab and pull out of terminations, then again, it's causing a stress on the installation, isn't it? So.
And we also have to recognise that specifically meter tails are different to any final circuit, in that the overcurrent protection for the meter tails is typically the DNO's main fuse, and they give us permission, as long as we don't exceed 3 meters, to actually install that without that allowing their overcurrent protection to do that job. And so we have to take additional care with meter tails, hence not only the clamps internal to the consumer unit, particularly on the Ellucian range we have that, but also put the compression glands on, and we do the other bits, and making sure the tails are fixed if there's any sort of thing, so that it's actually held back.
Held back to normally a wooden board, isn't it, where the supply head is. But again, it's a very good point, because we can't just stick an RCBO there, can we, and say, nope, they're going to be fine, because we've got additional protection now, because it's warranted by that DNO's cutout fuse. So there we have it. What a fantastic way to look at the evolution of cable supports and supporting the wiring system. Remember to like, share and subscribe the YouTube channel, and also drop a comment for any future technical videos you'd like to see from us, and we'll see you on the next video.